Okay, go ahead.
Okay. So just to recap, I'm talking about the back end of our overall architecture. So this is where we have the entire data imported, and I'll go into the steps in the upcoming slides. So we have the whole data into the HANA 1 instance, followed by applying machine learning algorithm on that, and then exporting the data using SAP HANA extended services so that it can be accessed by the middleware and then put on the mobile later. So now I'll talk about the upper part, like importing the data. So like I was saying before, we have two kinds of data. One is the flight history, which we got from this particular site, and then the weather data, which we need to invoke a few APIs and then download the data in the CSV format. As you can see, once we get the data in CSV format, once we downloaded it, it's about we wrote some script to index those files because primary key is needed for that data, and all the data which has been downloaded is imported into HANA. So this is the first step, or what we have done in our backend part. So this data is about like 250 million rows and like more than 50 fields, and you can see the huge amount of data which has been imported into the in-memory HANA database. So after importing the data, it's about, since we have huge data, you can see the 50 fields or like lot of data, it is necessary to select specific features, not all the features, like select a few fields and then apply the algorithm on that. So that is our next step. So once we have the data in hand, it's about selecting which algorithm to apply on and what all the features we need to select to apply the algorithm on. So now I'll tell about the selecting the features and the algorithm part. So now algorithm. So we have the data imported, and which algorithm to choose. So these are the factors we considered for choosing the algorithm. The first thing is the data is numerical and categorical, and like I already told, it has 250 million rows, and so it is huge data. So the analyzing is really hard, and also finding the trends in the data which is required to predict the results, like delay results. So that's the reason why and also we need to consider the predictive analysis library of SAP HANA. So wherein we have two options, the regression, there are a lot of classifications of regression, and the decision tree algorithms which are available in predictive analysis library. So this is where the SAP HANA development environment was really helpful. Like we need not go for a complex algorithm or do some kind of research and all those things. So it has already inbuilt algorithms which are existing, which support whatever our requirements are. So we were very happy about that. So then we chose the decision tree, and the reason for that is later we thought of using regression, but the current HANA version didn't support it for the categorical data, or like the data we had. So now the decision on algorithm is made. So we have the data imported and the decision on algorithm is made. So it's about applying this algorithm on the data. So in order to apply the algorithm on the data, like I have mentioned before, it's a huge data. So we just can't apply this algorithm on the entire data. It's about we need to select a few features for our specific requirement. So that is what selecting features is, selecting optimal features is about. So we have 50 rows and we need to select what all rows we need to consider to apply this algorithm on. So we calculated I'll tell how we have calculated the accuracy later. So if the initial accuracy is 0.75, say for example, and later we have like 50 fields. So we select one of the fields, we remove one of the fields, like say day of the month. And when we remove the specific field and then do the decision tree on the remaining fields, and we find an increase in the accuracy, then it means that without this field, the accuracy is more. So then we removed this field and like tried on the existing the other fields. So this is how we have selected the best features. So that is what we have written here, like run the algorithm against all features, then test by removing the features and keep the features that reduce the accuracy on removal. So this is the results of our whatever the analysis we have done. Like we have tested on all the 50 fields and then checked so you can see the first row over here I talked about till now, like initially is 0.75 and then after removing it is 0.79, then there is an improvement improvement in the accuracy, and that's why we had to remove day of the month. And similarly, you can see the other fields which he actually considered, departure hour and then visibility. So there are like a lot of fields just to give an idea of how our approach was. So we have algorithm. Okay, we have the algorithm now, we have the data, and we have selected the optimal features. So it's about clubbing all these things together. So here, this is the optimal features, and this is the imported data, and this is the algorithm. It's about all these things coming together to train the model and get a JSON output. So this is the internal working of the decision tree which I have been telling till now. So we have selected the optimal features over here, like all day of the month, day of the weekend, all these things. And this create table types is like the support tables which are required for the processing. Like you can see the JSON at the top. Why we have to create a JSON is the output, we need a JSON once we train the model. So training the model is very simple. Let me give it in simple terms. It's like we take 20 years of data. And since we need to predict the delay for 2013 or upcoming years, we need to create some kind of model on which we can apply this 2013 or 2014 data to come up with results. So training is nothing but 1993, say 1993 to 2012, all these years of data, which is in this part. We have created a view of that and applied the decision tree algorithm on this data with these selected features, which I told you before. So what you get as the output is the JSON, and the control tables. This is not necessary, like these are something internal. I don't want to delve into that. So once you get the JSON output, so now we have the model ready and everything is ready. We have the data, we have the model, we have applied all these things. Now it's about the predicting the result. So how we predict the result? Like I told you, we have trained from 1993 to 2012. We got the JSON output. Now it's about applying that output, like the JSON output, which was here. You can see the JSON here. Now this is the input here. And say this is the selected fields again. Say I said here delay group. So delay group is the delay. Say if the delay group is -1, it means the flight is 15 minutes late. If it is -2, then it's like 30 minutes late. So that is what is delay group is in our specific data set imported. So here the import data is the data to be predicted. Say 2013 today's date, and today's date a specific flight. I need to predict whether it will be delayed or not. So that is the 2013 data, and this entire model, the JSON model, is the model which was obtained in the previous step. So once you apply this trend on the 2013, say, today's date, like tomorrow's date, how the flight will be delayed or not, we'll get some result as the output, and this result is nothing but which specifies the delay group. So that's why we are not giving the delay group in the input, like in the selected fields, because we need to predict this over here. So once you apply the decision tree algorithm, the second part, on this 2013 present date to be predicted, you get the output. It falls in one of the delay group categories, say -1, -2, -3. I was talking like 30 minutes delayed or 20 minutes delayed, or those things. So this is how, like a very brief so here this entire thing is the working of decision tree. So it was very easy for us, or we felt very comfortable when learning this, because this is just because of SAP HANA development environment. We did like I told you, we did have to research a lot about what algorithms we need to use, because PAL, which is in SAP, is very nice to use, and we liked it. And so, okay, now we have the output, that is fine. So how accurate these results are? Do we know that what is the guarantee that the predicted output is correct? So for that, we have built something called accuracy model, and that accuracy is nothing but, once you get the delay group, like the delay group is -1 or -2, say, and we already have the 2013 data existing. So we have the 2013 data, and we have the predicted data, which is the output of this. So the actual data and the predicted data, the difference between both delay group of actual minus delay group of predicted by delay group of actual into 100. So the percentage of that is the accuracy which I was mentioning in my previous slides, the accuracy of 0.75, if you remember, like how to remove the field and all. So that is where I was referring to the accuracy point. So this is for all the months, for each and every month, January, February, March, and for all the months. And this is what I was saying before, like 20 years of training data. So once you train the data and apply that trained model on 2013, like today's date, you get an output, and that output's accuracy is tested, and this is the output you see. And you can see the accuracy is about 80% only. The reason for it is we didn't consider weather data here. So this is just predicted based on the historical data. So the same way, the same graph, I can put it in another way, maybe go into a detail. Like this is January, right? So these are the details of the entire January. So it's about, like I was saying before, it's predicted versus the real delay. So for only January, these are all the flights. So flight A, flight B, flight C. So for all the flights, the orange and the green are predicted versus the real. So you can see some variations at a higher delay group. So delay group high means maybe higher delay, like not more than 30 minutes or more than 2 hours. So for higher delays, we are not accurate because we didn't consider the weather data which I mentioned in my previous slide. So this is how we have tested our accuracy, how accurate our results are. And also in plotting these graphs, we didn't have to use any tool. It was very easy when using SAP HANA development. We just had to click view. There is some option of open data view and then plot the graphs then and there. So that was really, we like the way that HANA development environment has all these features apart from just the database. So of course that is what our motive of this project is, like to explore or elevate SAP HANA, and we're happy that we can see all these things. So we have predicted the results. Now let me show the diagram. So right till now I have been talking about the data, imported into the HANA instance, then applied the machine learning algorithm. Like all the details I've spoken till now is this part, the machine learning algorithm. So now we have the result and we have predicted the accuracy of the result. So once we have the results, it's about exporting the data, or the results we have, like delay group which has been, which we got the output as, is just a table or a normal data. So that has to be displayed onto the mobile. So that is again a different platform, say Android, or we can build an iPhone also, which is really a completely different platform. So this is where the concept of web service comes. So when we have to put the data onto a different platform, it's about the output has to be exported as a web service. So this is where the SAP HANA extended services feature we have explored. And again, this made our lives easy with the SAP development environment. Like the extended services which is already present in SAP HANA, we just had to use XSJS, like server-side JavaScript. We just had to write a simple JavaScript to export the results of the delay group, the result as a web service. Web service means it is JSON or XML, like we use JSON. So once we have the predicted result, we exported that using XSJS with a simple JavaScript in writing in SAP HANA development environment. And then I'll tell, like Lily will talk about middleware later. So we chose XSJS to export the data, and so that middleware can access and it can be put onto the mobile later. So here in extended services, we had a couple of options. One is XSJS or XSO data. So we were initially confused, like what to use, because the two options are provided by SAP HANA, and we were like, the thing with XSO data was very simple. You just had to write one line of code and export the data as a web service, and we were like, okay, this SAP HANA features are really nice, okay, just one line of code, we can just export the whole thing as a web service. But later, these were the drawbacks as in we couldn't explore much of XSO data, maybe due to our lack of experience with how to use this also. So then we thought, let's use JavaScript, which is also supported by SAP HANA. So we were happy that it supports XSJS as well. So these are the 4 differences which we noticed with XSJS. XSJS provides parameterized queries. So parameterized queries as in, like I gave it today's date, like what is today's? Okay, December 3rd, 2013. So when you give that input, the flight delay has to be predicted for today's date. So those are the parameters. Like given the parameters, it has to predict the delay. So those are the parameters I'm talking about. So that query was very easy with JavaScript. And like ability to query and export the views. So we found it difficult with XSO data. We couldn't retrieve the views to export as a web service. So, and another thing is we were familiar with JavaScript, so we had to that's another reason. And the stored procedures like decision tree, calling decision tree, or like other machine learning algorithms, it is very easy with XSJS. So these are the reasons why we chose XSJS to export our data, which is supported by HANA development environment. So that was really a cool feature of HANA development environment, which I personally liked a lot. So now it's about transition to the middleware, which Lily will be talking about.
Okay, so the middle layer is the job of middle layer is to connect HANA, taking advantage of the existing JSON model and PL procedures that we have trained, and send a response according to the Android request. So on this side is the middle layer architecture, and first when the request comes, there is a logic controller, and it will first pass the parameters, and it will call those three features. The reason why we are using those features is that we are using weather feature to get the departure airport, arrival airport forecasting data, weather data, so that it can give a user better overview of what's going on. And about the flat feature, we are using that because we want user to input just 3 parameters, and this flat feature will get everything about such a flight, like the departure time, departure airport code, and the departure city. And the YEP feature is based on the delay prediction. We are going to give the user some recommendation, like the nearby restaurant, nearby transportation or hotels. So after I called those features, there is wrapper will wrap up every parameter that HANA will be needed to predict delay. So this parameter has 2 ways to call HANA procedures. One is to use access.js, which is calling an existing access.js files. This file we have tested and guarantee it will run through all the logic to call PAL functions. And as a backup, we also has a JDBC handler, which will also wrap up everything to call PAL functions. So this middle layer is using Play framework. And we are exposing this service as a web service. So we use Play to define this GET request. The prediction is the action name, and the following 3 are the parameters. So this is example. When we call this URL, it will give such a response. We have many fields, so I just show a couple of important fields. First of all, there is an error field, which has an error code, which indicates if there is error or not. If there is error, it's 1, together with some error message. So this is important because we are calling external web services, we are using some flight APIs. So in case of the flight APIs is not working well, it might not give a good response. So in that case, we will show on the Android app the error message, so to guarantee that the app will not crash. And next, I will talk about the 3 features. The first is flight info feature. This is the service API we are exposing through our middle layer. So when we get those parameters, it first transform SS4 to longitude and latitude, and wrap up everything, send a URL request, HTTP GET request to api.flightstatus.com. So this is the result. It's giving back departure date, departure time, about the airline and the departure airport. And next is the weather feature. So it's doing similar thing. This is the previous API, and the weather feature will wrap up every parameter and send to api.worldweatheronline.com, and getting the parameters about weather, like temperature, humidity, visibility, so on and so forth. So next is the YEP recommendation feature. So this one is we defined another GET request in the Play framework. Recommendations is the action name and with those parameters. So when we send that request to YEP, YEP will give back some good format data. Like this one is recommending a restaurant near SFO airport. So about connecting, so this is the Access.js we have on HANA. So it has the logic to prepare the control parameter and call PL functions. The good thing of Access.js is that it has every call HANA APIs exposed as JavaScript functions, and we can use JavaScript to have easy access to HTTP request and response. And we can have a further manipulation over the result set after we finish the SQL query. And last but not least, it makes the application development much simpler, because after we make sure that it works well, and all the application side need to do is just send a HTTP request and get the response that is defined in the Access.js file. So it makes debugging much simpler. And this way, this is the JDBC connection to HANA as a backup. About the prediction, so the weather data we have, like the weather forecasting is only reliable within next 10 days. So on the middle layer, we will make a decision based on the time. If that date is within 10 days, we will call a procedure on HANA that has been trained together with weather data. Otherwise, we will call another procedure without weather data. So it guarantees to give better response to users. So now we'll talk about the front end.
Okay, so here's the front end part of our project, which is the Android application. Here's what it looks like, what it does. So first, it will get the input from the user, which is the flight number, the origin airport, and the flight date, in order for the app to call the middleware to get the prediction. And after the middleware, after the app gets the prediction, it will display the prediction result, and the user will have choice to get the recommendation of things to do around the airport or inside the airport. And for example, that would be the hotel, the restaurants, or the shopping places, depends on the situation, which the app will will ask the user of where is the user, and the user has got the boarding pass or not, for example. So here's how the recommendation system works. So first, it will get the current user location and decide what to do. So if the user is not at the airport, it will take the traffic time, the driving time from current user location to the airport, and calculate the remaining time and decide which choice which should be recommended. So if the user is outside the airport and there are a lot of time, like more than 24 hours, it will recommend the hotels, transportation, dining in this order. Otherwise, it will recommend in another way. So for this example, for the 4 to 24 hours left, it will consider, is that time the meal time? If it is the meal time, like the breakfast, lunch, or dinner, it will recommend the dining first, but otherwise, it will recommend the shopping places first. Otherwise, if there is not so much time left, it will recommend the user to hurry up, go to the airport, and then recommend the places inside the airport instead. So if the user is at the airport, it will ask the user, has he got the boarding pass, or has he passed the security check, and the app will also recommend what the user should do first, and then recalculate the remaining time by, for example, if the user has not checked in yet, it will minus the time left by 30 minutes, for example. And if it is a meal time, same thing here. If it is a meal time, it will recommend the dining places first, or otherwise it will recommend the shopping places first. Here's the example of the screenshot, how the app get the user input. Here, how is what it looks like for the prediction result. It will show the flight itinerary and with the predicted delay and the map. And once the user click on get the recommendation button, it will get the current user location and ask some question depending on the situation. After that, this is the recommendation result. We show everything This is from the middleware from the Yelp API, which will show everything to do, the things to do around the airport, and the timer, the time left, current traffic situation, and what the user should do. And once the user click on the recommendation of the service that he's interested in, the timer will show here, and when the user should leave, and the traffic situation from that place to the airport, and also with the map. The user also have an option to look at all the departure flights in a specific airport. And the user can also click on this one of these flights in order to see the prediction delay as well. So the user don't have to input the flight by himself. And here's the demo, the video demo. Here's the demo. So this is the screen, and once the user entered all the information, he clicked on the predict flight, it will get from middleware, and then here's the result. You can see the map, the current situation, the flight itinerary, and also the weather condition. And user can select get recommendation. It will get the traffic situation and the services around here. So it says, oh, you have a lot of time left, and it will take just half an hour to go to the airport. So the app recommends you to stay, leave later or stay at a hotel around here. So I think he will decide to go to this hotel. And you can see that this is, you have 28 hours left and just 5 minutes from this hotel to the airport. So you can leave you should leave before this time because the flight will delay. The flight will depart at this time, the 3 p.m. So you should leave at around 1 p.m. to do the check-in, get the boarding pass, and so on. So this is how it looks like for the recommendation.
So this being a class project, so we also need to look at how we went ahead doing this project and not just what was done. So the project itself, as we saw earlier, was developed as a showcase for the HANA platform, and we wanted a proof of concept mobile app and also a real application which has a potential market. So the requirements were challenging and vague. So the team really worked closely with the customer, and being agile, and we used the requirements were very agile, and there was a lot of room, so we worked iteratively trying to go ahead and do something about it. So we used a Scrum methodology to go ahead with this project. We had regular weekly meetings with the customer. We had daily stand-up meetings 4 times a week. We had 4 2-week sprints starting from October with a planning and a domain understanding phase before that. We used Asana for project management. We had informative workspaces. All of us sat together and coded. We used story cards to track customer requirements. And as you can see, like this, our workspace, all of us worked together. We made sure that at any point of time, there was more than one person aware of any task that we are doing, and so on. So we also did a very iterative development model. Like as you can see, the mobile app itself in the beginning looked something like that, just a basic UI with some placeholder text. And though we're showing only the mobile app, it was a full thin slice. Like we did have a working backend right then and so on, just adding steps at refining the model, improving the accuracy. That was what was done through every iteration. In the second iteration, the UI was enhanced, maps were added, but still recommendations were not available. By the third iteration, recommendations were added, some small usability enhancements were added so that you can see things clearly, bigger text and more usable and so on. So this was the way we went ahead with the development itself, and our client was very supportive throughout, which is why we did in such a model. Our client, who is actually here right now, we had weekly meetings with him, and he was very open to changes, and more than that, he also provided us with a lot of suggestions on what to do and had recommendations on not just how to do the project, but also how to project it and how to present it, which was really useful, since though some of us have industry experience, it's always been just as developers. And he also provided the direction, and he was more like a mentor than a client to us, really. So the challenges and future work, I'll just touch upon that. So our major technical challenges were due to the fact that we had to handle huge amounts of data. The data set was really large. We had like every single flight over the last 20 years to predict on. So we really saw that by reducing the amount of data, the accuracy goes down, which was not something we wanted to compromise on. So we worked with that, and that really resulted in some connection losses with the Amazon Web Services HANA instance. Integrating HANA with MVC frameworks was another challenge for us because we didn't have much experience with MVC frameworks or with HANA. And HANA PAL, the version that we were using at least, did not support automatic feature selection, so we had to do that manually. And also we were using an older version of HANA, so we couldn't use things like name base and so on. Other challenges were that the requirements were vague, at least in the initial stages, and we had a huge learning curve to use HANA, and large amounts of data had to be imported manually. And on top of all this, on November 18th, just 2 weeks ago, the Amazon instance crashed and we lost all our data. And it's bad enough to lose a database, but HANA was also our code repository. So we lost all our code. And that's when the team really came together. We contacted SAP, Jordan put us in touch with a few engineers. We contacted AWS, but they were not able to retrieve the data, so we re-imported all the data, retrained all the procedures. We had local versions of code lying in our machines, so we put all of it together, checked it all into Git. And what really helped us at that point was the fact that we had step-by-step documentation available, and we didn't have to relearn everything. All we had to do is just follow those steps and get it done. Otherwise, we wouldn't be here with a demo 2 weeks from when it crashed. So what I also want to say is what we did basically was the mobile app to predict airline delay, which included historical and real-time data. We made use of some optimal feature selection and analysis and created a recommendation system based on flight delay. And we also explored various HANA features, not just HANA as a database, but also as a code repository, as a predictive analysis library, using XSJS to expose the data, and also integrating HANA with the mobile app. And our results, it serves as a working prototype demo of HANA, and the mobile application itself can be used. So, and also apart from the application itself, the fact that it just takes a few seconds, even if you want to predict thousands of flights at the same time, was a real win for us. As future work, there's really a lot that can be enhanced in space, in the both in the back end, just in terms of the analysis alone, or on the front end, making UI changes. We can add interactive maps, we can add store user preferences, or on the back end, we can try something like name-based, which is supported in later versions of HANA, or do some more clustering of the data in order to, or support international flights. So there's a lot more that can be done, but we just wanted to present what we have done so far. And we are ready to take any questions, but we'll be disconnecting the presentation so that the next people can present.
Okay, so let's give everybody a round of applause. Okay, so disconnect because the next class has final presentations, and then we'll continue with Q&A. So Ed, come up and set up.
Any questions?
John? Jordan? Any questions? Give him the microphone.
Because I know what they're doing.
Yeah, this also works, yeah. Yeah, so Jordan's been more of a guide and a mentor throughout as well, and we've met him very regularly, so he's aware of what we've been doing and what's been happening.
John? You
I
too?
have been working with them until last night. My
Yeah.
question has been resolved.
Okay, but what's your response? I mean, what do you think of this? What about the
I may have
experience?
some suggestions for this case.
Yeah.
Sure. For the audience point of view, basically we want to see a architecture diagram. You have the people talk about this message one by one, but if you can give us a guideline of overall how the system is connected, how you separate, what is the interface between, not separate. Everyone talk about the similar things, how each one connected, separated. A high-level overview will be very helpful. The second is the feature selections. You do not read the final feature selection.
Oh yeah, we did not put that up
Yeah,
here.
you should tell the people what is the final selections,
Yeah.
and you show the diagrams that
Morning, Mel.
prediction is not correct.
I was on the.
Morning, it looks,
With the metadata,
yeah,
not
I
correct.
thought we were too, but it looks
So
like we
those
have
will be
one
very
team
useful
there
if
that
you
Jeff is their VP, correct?
Yeah. We were actually thinking of showing a
I'm sorry,
demo
say
of
that
that
again?
too, but then with all the issues we
One
were
team
trying to-
there, Joseph is their VP,
Thank you,
Enterprise
Joseph.
6.
Okay.